somebody remind me to record. So I am currently recording everything. Now I am. Which means I forgot to record the stuff from before. So no matter what, any one of you guys can stop me. So if you think I'm going too fast, let me know. If you think I'm going too slow, let me know. If you need me to stop and re-explain something, let me know. Okay, so like I said, discrete quantitative variables have numeric values that can be listed or counted. So we saw this already. 3-pointers, right? We can only throw 1 3-pointer, 2 3-pointers, 3 3-pointers, so on and so forth, right? A continuous one is something that is continuous. You can fill in those gaps. You don't have discrete values that they can take. Cool? So, which ones are quantitative variables, and of those variables, which ones are the continuous ones? What do you guys got? So, is a foot length quantitative, or sorry, is a foot length discrete or continuous?
Discrete.
Discrete. Continuous.
No, continuous, because you can get older, like, and like your legs will like get longer, or your feet. I mean.
Right. So in this case, the foot length would be continuous. Right?
You haven't been using your writing chart, have you?
Well, it's starting to glitch a little bit, so I mean, you guys can easily say like, sure, whatever. How about we try it again?
So once you get a certain age, your foot stop growing.
Yeah.
But he's just talking about that, like, it has to be a precise number. Like, height is a precise number, foot length is a precise number, but shoe size is like a general term.
Right, exactly. So
okay,
the shoe size would be something discrete.
Discrete.
Yeah.
Right? It's specific values that somebody's foot can fall on, right? So you're an 8, you're a 9.5, right?
Yeah.
Mm-hmm.
Those are the only values that exist in terms of shoe size, right?
Yeah.
Foot length, that could be any number you possibly can think of, right? Depending on how accurately you measure it.
Okay.
Continuous again.
Continuous.
Okay. Number of times a student changes her major.
Discrete.
This would be discrete.
Mm.
Does that make sense?
Mm.
Can you change your major pi times?
Yeah.
Yeah.
Really, you can change it pi times?
No.
Pi is some convoluted decimal number,
Yeah.
so you can't.
Pi is right.
Oh,
Convoluted
okay.
decimal number. You can only change your major 1, 2, 3, 4, 5, 6, 7, 8, 9. Hopefully not 10 times, but
So it's basically either. Okay. I think okay. Just keep going, and maybe I'll kind of get it.
it's specific values that your data can take.
So it's not really like either or. It has to be like one like option, basically.
Exactly. So there's an
Okay,
option for
that
you.
makes more sense.
You can get an average from them, right? But you can't. There is no decimal portion of it. Does that make sense? Or a continuous decimal portion of it.
Yeah.
Okay. Time it takes a college student to get to school.
Discrete?
Continuous.
Continuous.
This would be much more continuous.
Uh,
The reason being, right, is you can argue that it'll take me 16 minutes to get to school, right?
But a certain amount of seconds.
Right. You can measure it to a much more precise amount, correct?
Yeah.
Okay. Number of owl eggs in a nest.
Discrete.
Discrete.
This would be discrete, right? And then the
I have
weight.
no idea.
Continuous.
Continuous.
Continuous, because you can measure this, right, very precisely, and that weight can differ from egg to egg. Got it?
Yes, sir.
Boom. Okay. So Okay, yeah. So for this example, we have what's called probability distribution. So remember how I mentioned that if you grab all the probabilities, right, and put them on a graph, right, that's attached to their, or sorry, if you grab all the events possible and you attach their probabilities to them and put that on a graph, you have something called the probability distribution, right? Below we have two probability distributions, one for the number of eggs and the other for the egg weight. There's a difference in these two, one of them being the relative frequency and the other one being the density. So the relative frequency, that one's the one that you know and love. This is your good old handy dandy histogram.
That is discrete, right?
Right. And this one has the discrete one because the number of eggs, right? There's only specific values, right? 0, 1, 2, 3, 4, 5, 6, right?
Mm-hmm.
The other one is what's called, so the other one, the egg weights, that one's the continuous. That one is the continuous one. Because if you look at, these are egg weights, right, in grams. We can have any weight between 8 and 8.2 grams in there. Does that make sense? So an egg weighing 8.12583475938 grams can be in there. You guys see how that's what it means by being continuous? Got it? Okay. There is a difference between the two graphs, one of which, so this one is the histogram. It's the closest one that looks like your histogram, right? This one is a probability distribution that deals with the density. So what do I mean by that? It sort of gives the density of how often something happens within the grouping that's been given. So the way, I don't know why my computer is, no. Okay, there we go. Okay, so the way that this works out is, you guys see how big each one of these are? Each one of these,
0.2, 0.2.
right. Each one of these are 0.2.
No. Yes, 0.2.
Does that make sense?
Yep.
If you grab the 0.2 and multiply it by the density, the number that's above it, it gives you the probability of how often something falls in between that set. I know that sounds really wonky right now. So I'll explain it and I'll write what I mean. Got it? So the probability for this box right here will be 0.03 times 0.2, and that's going to be 0.06. Or as we like to call it, 6%. So there is a 6% chance that an owl egg lies between 8 and 8.2 grams. Does that make sense?
So far.
Okay, we'll move on and do the next one. Same thing, 0.11 times 0.2
Is it times or divided by?
times.
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 If you divide by, you'll just get a bigger number.
Right. Let's see. So this is going to be 0.022, which turns into 2.2%, which means I think I did that very first one wrong. Yep, I forgot a 0. 0.006, which turns into 0.6%.
So should we not write the first one since you messed up?
Just go ahead and change it. These are part of your notes.
Oh, you changed it now?
Yeah, I changed
Okay.
it. And that was my. So what's the next one? Tell me what to write for the next one.
3 times
Yeah.
2.
Right, the 0.2, which is
0.066.
0.066, which in percent is
6.6%.
right.
I'm breaking my neck trying to read these.
Next one. 0.78 times 0.2, and that turns into 0.156, and that is the 15.6%. Cool. I'm running out of space above, so I'm going to go inside the boxes. So this is going to be 1.31 times 0.2. And 262.
I'm the best. Here you go. Put it right there.
How are people doing? Are people stopping me for some reason? Stop me if you guys need it.
I'm just gonna write them on the side because I can't really read that.
I know. I think for you guys, really, well, you guys have printouts. It's easy for
Yeah.
me to put numbers in, so that's why I'm doing that.
Ours is black and white.
So I understand what you're doing, but like, why are we doing this? Is this finding like the density or?
So the end result, that's a good question. The end results are the, don't you love it when your tablet screws with you? Let me put this back 0.6. So the end results that we want are these right here.
Okay.
So, and then this one right here. I don't think you're able to see that one very well. My tablet's screwing with me right now. Let me change it to, okay. This one right here. Let me write out the rest of them really quick. 22 times 0.2. 0.244. Okay. Ruben asked me to slow down. Sure, I can slow down. And the recordings, I'm trying to figure out how to do with the recordings right now. They may be too big to put on Canvas. If that's the case, I might turn into a YouTube star. So if one of those, I'll keep everybody informed on what's going to happen with that. But I am recording. Recording will go online somehow, some way. I'll try to figure out a way to make them accessible to you guys. Okay. Let me write down the rest of them really quick. Let me actually go back to writing above the boxes. 0.3 times 0.2. 0.06. This one I know I got right. This is 6%. This is 0.1 times 0.2, which is 0.02. Whoops.
On a totally unrelated note, happy St. Patrick's Day, guys.
That's true. When is it? It's today, right?
Yeah,
Aw.
but you can't pinch anyone because, like, you don't want to spread germs.
Well, I didn't want to pinch anybody. I wanted to do something else.
Just put on some gloves.
Green gloves, of course.
I didn't even know it's St. Patrick's Day. It's weird.
Yeah. Wow. Okay, so like I think it was Madison that asked, why the heck are we doing this for? And the answer to that are these numbers
R.
here.
That answer R.
Huh?
Love your English.
So see those highlighted values above each one of the bars? Those highlighted values are now our probability. So what we essentially did was grabbed what's called the density functions, or the density graph, and we turned it into a plain old histogram, like the one that's on the side.
Oh, okay.
Does that make sense? So, for example, right, if we look at this one right here, right, we know that there's a 24.4% chance that an egg's weight will be somewhere between 9 and 9.2 grams.
Okay.
Does that make sense?
Yeah. Oh, because it. Okay, I think I get it.
Okay, so now that we have our percent, now we can go ahead and start answering these questions at the very bottom. Before we move on, Ruben, you good? You feel to write those two down. Cool. All right, now we can answer these questions, and we're getting into like the good stuff now. This is the stuff that statisticians do a lot of. Use the probability distribution to answer the questions above. So we already have the probability distributions now, that both of these, right? What is the probability that a boreal owl's nest is empty? Which one of these two are we going to use?
The frequency.
Right.
Frequency.
Right, the relative frequency. And what's the probability in this case?
20%.
What is it?
20%.
What
Point
what
two.
bar? Right. We're looking at this bar right here. So that is our relative frequency. We turn that into a percent. 0.2. That turns into 20%. So 20% chance that an owl's nest. Cool. Okay. What is the probability that an owl's egg weighs more than 9 grams, but not more than 9.2? Which one do we use, the left or the right?
The right.
The right one. And specifically, what column are we looking at?
The 9.2 or the.
The 9 to 9.2 column.
Right. We are looking for. Whoa. We're looking at that one right there. That tend to be a little tiny. So we're looking at this column, right? This column. And that's why we computed the percentages. So now we can answer flat out what the percent is. You good?
So even with like different information, like a different problem, not asking about egg weights and its density or whatever, if it were different variables, it would still be the same thing though. It would be like the number or whatever that is, times like the distance between, and then just change to a percentage.
Yes. So this one deals with density. If you ever deal with density, you have to do this extra math for it.
Okay.
But it's a simple thing, right? It's just tedious.
Yeah.
You have the relative frequencies, right? Then these are the decimal values for your percent. So all you got to do is turn them into percent. So in this case, this one would be 25%, right? This one also would be 25%.
Mm-hmm.
This one would be 10%. 10%. Got it?
Yeah.
Okay. Last question. Is it unlikely to find an owl egg that weighs less than 8.6 grams? Why do you think so? So first of all, let's answer the first part. Is it unlikely? And then we'll say, why do we think so?
It is unlikely
Yeah, it's unlikely.
How do we know?
because there's a
Very low.
9.4% probability that it
You
is.
get that 9.4.
I added up the probabilities from
From where?
8 to 8.2 to 8.4
All the way up to 8.6.
to 8.6.
Right. Does that make sense? So I'm going to get rid of these. We are looking at specifically 3 of these boxes. We are looking at this box down here, right? This one, and this one. Three boxes. What's the probability of landing within these 3 boxes?
9.4%.
Right, and just how Connor had said, we add up the percents that pertain to those 3 boxes. So that's 0.6 plus 2.2 plus 6.6. So you write that down. Would I say 0.2 plus 2.2 plus 6.6?
0.6
Yeah, the first number is 0.6.
No, 0.6.
plus 2.2
Plus 6.6, and I think Connor, you said it was 9.4.
Yeah. Unless I counted wrong, but whatever.
Yeah, whatever. You have the right idea, though. So, we have our percent. Do we think that's unlikely?
Yes.
Why?
Because it's not even a tenth.
It's not even a tenth of percent. So this is this is not too much smaller than 10%, right? And 10% is about 1 in 10 eggs. So we're all saying yes. I swear I'm not trying to write like this. How we feeling?
Yeah.
Okay.
I feel okay.
All right. So how about this? It's 1:51.
Mhm.
I do still want to give you guys a break. You guys want to run off for a break?
Yeah,
I want
walk
to
around my
connect.
house.
Huh?
Walk around my house.
Around your house.
Take a lap,
Take a lap. Go outside. Breathe some fresh air.
but don't eat your ration food, the one that you're saving.
Don't eat your ration food.
All right, bye.
All right. Bye. I think I'm gonna give everybody maybe 10 minutes. So we'll come back at around 2 o'clock.
Okay.
Yay.
Don't go nowhere.
Oh, I won't. I'm actually gonna put my camera on again. Oh my god. Just thought I want. Oh.
I had a quick question.
Yeah.
On you know like on Fridays how you used to go to the math lab to get some help for
Yeah.
us like pretty much all day. Can you make it like where we can like get some help through Zoom on like Fridays or something like that?
So, I mean, that was my suggestion to the math department in terms of how to conduct math lab hours. They haven't really decided yet.
Okay.
So, I mean, no matter what, I think I haven't fixed up how I'm going to do my office hours yet. I think I'm going to do something similar where everybody knows my office hours. I'll just sign on to a Zoom meeting that will always happen, right? And if I'm there, my office hours. If I'm not there, you're just going to be in an empty Zoom meeting.
Okay.
Does that make sense? But we're still trying to figure that out.
Okay. Cause yeah, doing this like I always pretty much go to the math lab, do my work, and if I need some questions, I will go ahead and ask. But since I don't have that opportunity no more because it's closed down, then
Yeah.
I'm gonna see how well I do in the course now. That's happening.
There have been people that have been worried about that. It's not only you, Ruben.
All right.
And I've heard of from other instructors that because of the move toward online, people now don't want to do the class anymore. So there have been other instructors that have had some of their students drop.
And when is the last day to drop?
Crap, I don't know. I think it's April 28th. So you've got a ways out.
Okay, cause my financial accounting class is real hard, so I might have to drive. But won't that affect our free tuition program thing?
I don't know yet. I brought that up to the meeting. I brought that up to the meeting. There hasn't been an answer yet.
Okay.
So I'm gonna just assume that all this is unprecedented, right?
This is completely unprecedented.
Yeah. So
You guys wanna
just
know-
like any administration, they're just headless chickens running around.
Right now, yes. Definitely. The last time in history that this has ever happened, does anybody know?
What, an outbreak of disease?
Yeah.
I could think of a few. There's the plague, Ebola in Africa.
How about the
That
the first time that it's ever happened where I guess the civilized world knew somewhat what to do and it didn't kill off half of us?
Oh, yeah. I don't know that history.
I think Talia got it in the 1920s. We had the Spanish flu. It killed a fair amount of people, and most of the world decided to self-quarantine themselves.
5648 Main Street in Emeryville. And at the time I applied for her, I requested that the mail be sent to me, but I don't know if because she was a provider at one time, it just automatically went to her address. Okay. All right. 521.
I want to try this out. Let me see. I'll do it next time.
Other parts of New York. Schools closed in New York City, Long Island, and West County. Restaurants and bars in New York City also required to shut down, except for food delivery and takeout. Cuomo also calling on the federal government to use the Army Corps of Engineers to build temporary medical facilities, issuing an executive order to increase hospital capacity across New York. The governor pleading with every New Yorker to stay calm.
And then I also had another question. Did you get the test graded yet?
Not yet.
Or not yet?
Not yet.
Okay.
How are people doing?
Pretty good. Pretty good.
Fine.
Julio, I have a random question.
Okay.
What's your favorite ration food so far?
Ration food?
Yeah.
Oh man.
Shit on a shingle? Question mark.
Let's see. It's not favorite ration food. Is more like the only ration food that I got, and it's those it's the Trader Joe's the little cookies from Trader Joe's. So I have
the little like chocolate chip ones.
yeah.
The mini ones, those are literally the best.
Those are the best.
So it's not actually the cookies that I'm eating. It's the they're called like coffee dunkers or
It's
whatever.
the wrapper he's eating.
The wrapper.
So it's so they're long cookies that like one side of them got dunked in like chocolate. You're supposed to some coffee.
Yeah.
That. Oh boy.
Those are good.
That sounds like you could do that and coffee. Ooh.
Yeah. They have like biscotti ones there too that are pretty
Right.
good.
They look like biscotti.
Yeah.
Except like imagine like one of those really, really good Trader Joe's cookies just like stretched out with one side dunked in chocolate.
Might have to go see if they still have those. Actually, we're supposed to stay home. I forgot.
Yeah, we're supposed to stay home.
Yeah, when I was at work yesterday, there was a line for Trader Joe's that was wrapped all the way to like the famous footwear across the street.
Oh wow.
Yeah, it was crazy.
Are you still busy at work, or like can you not go inside?
It's like
just
Popeyes when their sandwiches came out.
Yeah, we have to for In-N-Out. We're doing takeout only, and we have to monitor 25 people in the dining room, which is technically like not the legal limit, but
Isn't it like
Yeah,
10 or
way
something?
around.
It's supposed to be 10. I think.
Yeah, it's supposed to be
My
10.
hours got cut a lot.
That sucks.
Yeah.
my restaurant I
And
work
you're 50% off this week too, so it's kind of weird to me.
What's 50% off?
Domino's.
Oh, Domino's is? Wow.
Yeah, everything is like 50% off, and usually like we're really busy because we have like it's like a week-long special, and it's like once every few months. And so like my hours got cut, and we're I think we're super slow.
Yeah.
And they're doing this contactless delivery thing
Right.
where like they send us an instruction sheet where like the delivery driver like puts their a barrier down as like on the ground, and then they put their heat bag on the ground, and then they put the order, and then they have to stand 6 feet away from the door, and the person has to get the food, and then the delivery driver leaves.
What? Wow. That's
You might as well just
scary.
drop it, hit the doorbell, and
Yeah,
run.
doing too much. Because the
Drop it
person
at
has
the
to sign the
door.
receipt. That's why.
Drop it at the door and run, huh?
Yeah, I feel like that's so awkward.
It is, but that's, I mean, it's to keep people safe.
But I feel like this is not like a deadly disease though. Like everybody just freaking out. Cause
Yeah.
at Walmart, I be reading the people that be buying like $500 worth of food, $600 worth of food. Like it's like, well, I get that it's, well, those that are panicking because of that virus are making those that don't want to panic have to panic to get some food so they
Yeah.
can survive.
Yep. Yeah.
But Walmart's making a lot of money, so they're fine with it.
They are. You guys hear that that guy in Tennessee that like had garage load of hand sanitizer, had to give it away?
And I heard cause I went to go cut my hair today, and then my barber said somewhere like in Sacramento, someone was selling some toilet paper. One single roll for like $10-15.
Oh heck no.
It's called capitalism.
Yeah.
Smart.
And then no, but he got arrested though. But I told my barber, how can he get arrested for it? It's just a business.
Where was he
pretty much.
doing it? That's the question.
I don't know.
Yeah.
Because if it was like on the street, don't you need a permit?
Yeah, like a business license, because that's considered a business at that point.
Yeah. And there are laws in the state for price gouging. So like you can't hike up the price of something that's like required for everybody past a certain limit. So I think the limit, I think by and large over the country, it's you can't
Well,
more than like 10%, I think.
how do you define something that's required for everyone? Because humans have lived without toilet paper for most of their history.
True.
So there's a good argument that it's not required.
But I mean, it's a necessity now, in the day and age that we're in now.
Yeah.
I guess.
That's essentially like sort of like a whatever local government is, right?
Mm-hmm.
It's essentially their call at this point.
But also, you said we have certain limits to where we can charge certain things, but isn't when there's a monopoly, can't businesses just charge whatever they want to at that point because they own everything?
That is a good point. Right? And it doesn't even have to be a monopoly, right? It can be
a trust.
No,
or something that they want, and then they just know that the supply is so that the demand is so high that they're gonna raise up the price.
Right. So, like for example, like a monopoly means just one person, right? Or
Yeah.
one thing, right?
Yeah.
It's the one that that it's essentially a monopoly, but like with 3 or 4 people, right? It's not a monopoly, but it acts like one. So the big one that
Isn't that the trust, like the railroad trust that got broken up and
Yeah.
stuff?
I think it might be. So like the one that I can think of off the top of my head is cell phones, right? So
Yeah,
a
like
cell phone company,
AT&T, T-Mobile, things
right?
like
There's only AT&T, T-Mobile, Verizon, and
that. And
Sprint,
Sprint. Yeah.
right?
And then like Boost Mobile, Metro, and all that are
Those
under those
are those
companies.
big 4 though.
Yeah.
So Boost Mobile belongs to T-Mobile,
T-Mobile. And Metro belongs to T-Mobile too.
right? So in that case, right, what keeps those 4 cell phone companies from saying, you know what, I want to charge $1,000 a line?
Those other,
Just stop using cell phones.
Yeah,
well,
they're gonna stop using, like people are gonna stop using cell phones, but what keeps them from doing it?
like let's say like T-Mobile puts their price up to like let's say $1,000, but AT&T sees that and says, "All right, we will put ours to like 800 to like $750." Then people will likely go to AT&T, and then let's say like Verizon sees that and then lowers their prices lower than AT&T, and then they will keep on making it lower and lower and lower, and then once the market gets set, that's what everybody is about to keep on buying them for. So that's what every company is gonna set the price
Right.
at.
Right, but then it's all 4 companies setting at that price.
Yeah.
Does that make sense?
Yeah, like also like gas. Like gas once
Same thing with
a
gas.
price, yes, because like when prices go up, like even like Shell or Chevron right across the block, they sometimes have lower prices, but also usually the more traffic coming with those that are selling it for the lower price.
Right.
But then that one that has a higher price will kind of have to lower down their prices so they can get more traffic and then more sales.
Right.
But they can't go so low that they stop making a profit.
Well, yeah, that's all about business though. So you gotta just
But
know
it's
about what you paid for and then what your profit margin is, and then just try to make a solid profit.
yeah.
Well,
But
one thing I do know is that according to WHO, runny noses is a symptom. So I'm gonna just buy up all the tissues so that way everybody has to use toilet paper as tissues, and then they run out of toilet paper faster. For all the toilet paper hoarders out there, you're welcome.
Yeah.
Yeah, I saw like one person buy like 3 cartfuls of just paper towels, toilet papers, like napkins, everything like that. I was like, man, this thing
Yeah.
hogging up all the things that we can't even use now.
Yeah.
But that's
Let's get back onto this. I actually gave you guys a bit too much time there.
20 minutes.
Yeah, 20 minutes, I know. I'm bad at keeping track of time. I mean, today not too big of a deal because one of the primary things that I wanted to happen today was that people get settled into the new model. So no biggie, but when we meet back again on Thursday, this will probably have to pick up a little bit. All right. Specifically, what we're going to do for the majority of the rest of the class is we're going to talk about bell-shaped probability distributions. And those have a nice name. Those are called normal curves. Anything that looks something like with the one middle hump in the middle, like this, is called a normal distribution. Got it?
Yeah.
Okay. There's a big reason for why we only look at these, or primarily look at these. And we'll get into that later on in the course. What I wanted to do is again, we're going to go back to probability distributions, right? And in histogram, okay? What we have here is, so the density curve is the thing that we were doing before, right? Where we multiply, how wide is each one of these? How wide is each one of these right here?
1.
0.5. Oh.
Oh, those. 0.2.
Close.
0.25.
0.25, right? My pen is glitching, which is super freaking annoying. Right, each one of these is 0.25. So if you put two 0.25s together, you get the 0.5 that you guys were all thinking of guessing, right? And notice that within these graphs, there's you guys see that curve that's there? There's a superimposed curve there. That's the normal distribution. That's the normal curve. We give you a picture of it separately on the side. Cool? So, what is the probability that a boreal owl egg weighs more than 9 grams? Use both to find the probability. So, we need, from this graph, we need everything from where to where?
9 to 10.
9 to 10.
Right, we need everything in these, right? We need everything in here, everything in here, everything in here, and everything in that little strip down there. You guys got it? Whose volume is up loud? Can somebody turn down their TV?
Yeah, that's probably me.
Probably you. Okay, can you turn it down a little bit, Leon? There you go. Okay, so what's the probability for this one right here? Or what's the percentage for it?
So you would do like 1.2 times 2.5, right?
0.25.
0.25.
Yeah. So then I'm going to go ahead and start writing those in. So then this one is going to be 1.2 times 0.25, which, did somebody do it yet?
It's 0.3.
0.3.
0.3. What's the next one?
0.155.
0.155. And what's the one after that?
0.04.
0.04. And then after that?
0.01.
0.01. So 0.3 is the 30%, right? Next one after that is 15.5%. The one after that is 4%. And the very last is 1%. So now, what's the probability that the owl egg weighs more than 9 grams?
50%.
Okay. Does that make sense visually?
Yeah,
Yes.
because the mean is in the middle. So then.
Right. So pretty well split down the middle, isn't it? Does that make sense?
Mm-hmm.
So half of the probability. So And like people have been saying, right? That right there looks like it would be the average, right? Half the eggs happen above that. Cool?
Do you want us to round?
Uh, sure. So long as it's not too far off.
Okay.
Yeah.
Like
Okay.
round 50.5 to 16.
Oh, that I think is good enough. So if you give me maybe, I'd say maybe 1 or 2 decimal points, that's fine. So long as you show me the math that goes behind it.
Okay.
Okay. So this is doing it using this graph. So we get a very precise number this way, right? Now, all the data that we grabbed from this graph right here, the egg weights, right? We can find an average, the mean, right, and a standard deviation from it. And we can calculate what this is. Sort of, we need everything from here on down this way, correct? We can find out actually how big this is. And the way we do that, this is another thing that we can use StatCrunch for. So what I want to do now, I'm going to show you guys how to do this on StatCrunch. So let me switch my, I need to switch what I'm showing you guys. So here is my StatCrunch. Everybody see my StatCrunch?
Yes.
Okay. So if we go over to, yeah, in stats, in calculators, and we scroll down to what we called the normal, you should get something like this. We're going to go ahead, put our mean and our standard deviation in, just how it's given in the problem. Cool?
Yeah, but I just want to know, how did we get a standard deviation of 0.3?
In this case, I'm giving it to you.
Okay.
Does that make sense? Don't worry where it came from.
Okay.
Just pretend that the standard deviation is 0.3 though, for this problem.
Okay.
Got it? Okay. So our data has a mean of 9 grams, right? With a standard deviation of 0.3. So that's how much on average my data deviates from the mean. Cool? Okay. And the original question is, I'm going back to my notes,
What is the probability?
that an owl egg weighs more than 9 grams. Does that make sense? So that means that we have to go
X2.
So we need our X to be
9.
bigger than 9. So we need the other one. We need it to be bigger than 9. And then if we compute, so the thing that we want to look at is that 0.5 that happened next to it. So this 0.5 that's here. You guys see that?
That's a 50% chance.
That is my 50% chance.
But isn't the what's that thing called? Where the X is, that box right there where it shows the mouth going into the X, shouldn't it be flipping the other way? Because it says greater than 9.
Right. That's what we need. The original the problem from your packet says, what is the probability that an egg, the weight of an egg is going to be greater than 9 grams?
Okay.
That's why we had this one, right? The X is greater than 9.
Okay.
Got it? And notice what we're shading, right? See how it's from 9 bigger?
Yes. Yes.
So that's the visual and the numerical interpretation of our probability.
Okay.
Got it?
Yes.
Okay, so what do the 68, 95, and 97 ticks mean?
Whoa. Slow your roll.
Oh,
We'll get to that.
okay.
So what I want to do is I'm going to do a screenshot for it from StatCrunch. I'm going to copy it into our notes. There we go. So I'm going to go ahead and share back the stuff that we were doing before. Let's see. Where's my stuff? There it is. All right. Everybody see my notes again?
Yep.
So what I want to do now is I'm going to put in that printout that we got. Whoa. Let me undo that. That's not where I wanted it. I wanted it over here. There we go. Thank you. I think I might need to restart my tablet.
Uh-oh.
It's a sign that you should just cancel class.
And so it begins. From StatCrunch, 50% from over there. Got it? Okay, so I'm going to try something out with you guys. So this is me playing around with this system. I am going to break you guys out into smaller groups. I want everybody within your groups and within your breakout rooms. I want you guys to try and answer 4 really quick. It's going to take you guys maybe like 5 minutes because I give you the printouts for them already right there. Got it?
Got it.
So you guys might
So
need
you're
to.
gonna put us in our groups?
Yep. Well, random groups in this case, but yes. So
Wait, doesn't it just tell you the
Oh.
answer right there?
I want you guys to discuss. Make sure you can answer it.
That's
All
all
right,
four.
Oh, so we're not doing our regular group?
Yeah, I can't stick you guys in your own regular groups. The ones that you had in class, I don't think it's letting me.
Try.
Let's see, maybe I can try. No, I'd rather do it automatically. Let's go ahead and try to do it automatic. I want to see what's going on. Okay, I'm going to let you guys break out. You answer them. Cool? Let me see. I wonder if I can, oh.
And then we just hit join, correct?
Yep.
Okay.
Number 4?
Well, I'm just thinking of it because it shows us the answer here. What is the probability that it weighs more than 9.5 grams? Everybody gives us the
This 4.77.
Yes, and then you just turn that into a percentage,
Yeah.
which just times that percentage by 100, and that's your percent that you get from it. 0.079. I got 4.779. Also 4.8%.
You said 0.16 times 25, right? So it would be
.04 for the .16 ones.
Oh, 4%.
Yeah.
Yeah.
And then 1%.
So it would
for
be
the next one.
4% and 1%.
Yeah. So 5% in total.
5%.
So 5% in total.
Yeah.
So no talking here, huh?
We were talking.
Yeah, we did.
Yeah.
It was just a quick discussion.
Yeah.
You guys had like the real quick, yep, I'm done.
Well, yeah, like Connor said, it's especially if you've already done the module 12 online stuff, you know that the answer is the .047.
Yep.
Yeah. If we have a specific question about one of the questions on the end of the module test, can we like DM you or something like that?
Yeah, so I'm gonna stay on afterwards, after class is over, which is gonna be in what, 20 more minutes?
Mm-hmm. But like I still want to retake it and get the question right. So is there like, can we like phrase it differently but have it be like the same general kind of question?
What do you mean? Something online?
Yeah, like the end of the module test, the 100-point ones. I got 93 on it, and I've only taken it once. But the question that I got wrong, I don't really. I guess I just don't get what it's asking entirely.
I think the quiz itself you can take 3 times, and it'll register. It'll keep the highest. Yeah, it'll keep the highest grade.
Okay.
So try to go on it again. If it doesn't, let me know. I can clear the exam and try it again.
Okay. Something wrong with your mic.
Yeah, I think let's do. There you go.
Wait, so we're not going to be having like online tests and everything, right?
We might need to.
Oh.
We might need to. Yeah.
I'm sorry, something's wrong with my mic. What did you guys get for the answer?
Wait, is
047.
47.
Oh, okay, Anna, your mic is working.
Yeah, I had to leave the chat. Something was wrong.
Okay. All right. I think everybody else is quiet at this point. Yep. All right. I'm going to close the room so I can bring everybody back.
Okay.
All right. We're slowly starting.
I can't see
Repopulate.
I
Huh?
can't see your video.
My video?
Yeah.
How about now?
Oh, yeah, I can now. Thank you.
I don't know why people have. Well, maybe people are rejoining right now. That was actually pretty cool. I was bouncing.
Yeah, that wasn't bad.
I could not hear anyone.
Well, I can hear everyone twice.
Someone's
mic is echoing.
Somebody's mic is echoing.
Oh.
Hello.
You just spit this out.
Antonio, I think it's yours. I heard it in our breakout room.
Okay, what I'm gonna try to do. I'm gonna mute everyone. And we'll try to turn on everybody's mic. Let me see.
There is an echo.
Yeah, it's coming from in.
All right. So everybody try to turn on your mics again. Let's see who it is that has the.
Hello.
Hello.
I think it's working now.
We were doing good in our little breakoff groups.
Yeah. What's that all about?
Hello?
It's echoing again.
It's echoing. Is it me?
Still echoing.
Oh boy. Hear myself.
Way too. Okay,
All right.
this is like
Antonio, mute yours.
All right.
All right, let me mute everybody. I think we might need to do the
Figured
hand
it out.
raising.
We figured it out.
You figured it out?
Yeah.
it was Antonio's mic.
Yeah, it
It
was
was Antonio. Okay. Antonio, try to turn down your mic if you can. Either that, or you might need to do the like turn on, turn off your mic as needed.
Yipper.
And you will need to say over every time you turn it on and off. Like, I have a question, over. All right. So, what people get?
Wait, were we supposed to do number 5?
Number 4.
Okay.
I
But
told
not-
you.
Okay.
The histogram gave you 5%. And
Yeah, we
the,
got the same.
Right. Specifically, what was the actual percent? Where would we find it?
4.7%.
Yeah.
Right. It's this thing way over here. Right. And if you did the math for it, it would be these two. Right. So anything 4.7% or 5% sounds legit. Cool. All right. I actually like that. That was pretty fun. Okay, so I want to do some group work now. Same thing, I'm gonna split you guys up. You guys may not be in the same groups that you were in before, but how about we do 5 and 6 in our groups? I'll give you guys 10 minutes about. Cool? And I will, it will break out into the same rooms. All right, I'm gonna send you guys into your groups.
The probability weighs more than 8.5, but not more than. We look at 0.62 and 1.19, right?
yeah.
And then that times 0.25.
Mm-hmm.
Okay. Okay. 62.
So for you guys, try to go and hopefully you guys have another device so you can have StatCrunch open.
Yeah, I got it open.
Yeah, so try to, so you guys probably got a value, right? Try to go on StatCrunch and see if the normal distribution version, like whenever you do this thing, right, is the same thing, or at least
So,
close.
on StatCrunch, how do I make it so it's between the 8.5 and the 9?
So if you look at the picture that I just put in, so let me go actually to the picture for, you guys can still see my screen, right?
No.
No, okay.
I mean, I can share my StatCrunch so people can see it, I suppose.
Yeah, you can. So if you go to the normal calculator, the thing that I made a picture of.
Yeah, can you see it, by the way?
Yes.
All right.
Can you see it? Let's see, because I can't.
I don't know if you can see my StatCrunch or not. I can't see what I'm sharing, so.
Yes, I can see it.
Okay. Oh, between, gotcha.
There's a between option above. So in there you can, right?
8.5 and 9. So
Got it?
like that. Okay, so, okay, yeah, I got it.
I guess it was a 45.2%.
Yeah.
Oh, there it is, Yeah, I can see your screen now. All right, you guys know what you're doing.
Okay, that makes it really easy.
Yep.
All right, cool.
Oh, he's
29
starting.
point.
He's
Huh?
starting.
29 point. Huh?
What?
Our teacher's in here.
What?
What?
What? Oh my god. Oh my god. Okay, what do you guys got? Okay, what do you guys got?
We're doing it.
We're doing it. Right now we have 15.5%.
Okay, so you guys probably got an answer. Well, let me share this really quick.
Okay. I got an answer.
Where am I? Okay. Just like for this one, you guys have an answer that has the number from, let's say this one, right?
Uh-huh.
Let me actually go to number 5. My thing is acting. There we go. So you guys probably found an answer. I'm beginning to hate my tablet. Somehow, some reason, it thinks I have to go to the very beginning of the chapter, and Ugh. Okay, you guys probably have an answer. using this.
Yeah, we did 0.6
times
times 0.25. And then we got 15.5.
Right. Try to do similar using StatCrunch.
Oh, we have to use StatCrunch now. Okay.
Yeah. I want you guys to start using the StatCrunch.
All right.
Cool?
Yep.
Cool.
Okay. You guys know what you're doing. I'm gonna go terrorize another group.
Okay.
Okay. All right.
Are you guys
And then
good?
for yeah, I'm good for that side. Are you guys on number 6?
Yeah.
Okay, so for number 5, make sure you know how to do it by StatCrunch. So you guys know when we did this thing?
What?
Oh.
So you guys know, so hopefully everybody's looking at my screen right now.
Yeah.
You guys see how we did this one where it's greater than 9, right? There's this option for between where you can put 2 values if you need it between something and something. Make sense?
Yeah.
Oh, okay.
Shouldn't be too far off from your sort of exact answer that you got from using the other graph. Does that make sense?
Uh-huh.
For 6C, how were we supposed to show that? Because it's hard to, without doing it on StatCrunch, it'd be hard to do the one standard deviation, right?
Right.
Because I know it's 68. Because if you do the module 12 stuff, it goes all into that, like the ticks or the percentage.
Right.
But I don't know how to show that.
Yeah. So if you, let me share another screen. Let me share the original notes. So I'm going to make this tiny and I'm going to scroll so that we can see. My computer's being all laggy. So at the very top here, they give you a standard deviation and a mean. Right?
Mm-hmm.
So from here, right, you can use that stuff and you can put it in StatCrunch itself.
Oh, is this sorry to interrupt. Is this the what is it? The mean minus the value over the standard deviation?
We're not there yet.
No. Okay.
Yeah, we're not there yet.
Okay.
We're about to. I think that's module 12.3.
Oh no.
Yeah. So then our mean, I think it's at 7.
7.7.
7.7.
And 1.1 for the standard deviation.
And 7.7. And then 1.1 for the standard deviation.
Yeah.
Right?
Mhm.
So from here, fill in whatever these need to be. Right?
Mhm.
And then hit compute. That'll give you the percent using the normal calculator.
Mhm.
Got it?
Yeah.
Okay. Seems like you guys know what you're doing. I'm gonna go terrorize another group.
All right.
Let's see, who else can I scare? Who can I scare? Let's see. I'm gonna go scare Connor's group. Haha. Unfazed. This group unfazed.
Yeah, so we totally forgot what we were supposed to be doing. So we've just been sitting here quietly the whole time.
Oh no. Problem 5 and 6.
Okay. For 5, I think we just use Stat Crunch, it says.
So since I give you guys a graph, let me show you guys 5. Since I give you guys a graph for it, right? Use the stuff from, I think it's still, yeah, it's still talking about problem 4. Use the stuff for problem 4, right? Do it both ways. Do it using, you guys are seeing my screen, right?
Yeah.
Do it using this one. This one you can calculate out, right? And then do it using this other way where you use Stat Crunch. That's the thing that we're going to be transitioning to in not too far future.
Wait, I have so for B, it says to verify that your answer is close to the Stat Crunch estimate.
Right.
Basically, isn't it the same estimate, even though, because it's just on the other side, really?
It's, so.
Because isn't it like a little bit
do
less than 2 standard deviations?
Yes.
So it's
if
like
you
the
do
same
it this
interval.
way, right? If you do it the way with the density function, you'll get a number and you'll get something much more exact, right? This is actually sort of extrapolating a little bit more information from it that may not be there. Does that make sense? So this one will be a little off from our answer from this one.
All right, but my question is, so because the Stat Crunch thing, it's using 9.5, but since we're using 8.5, which is literally just the same thing but in the other direction,
yep,
I take it we could still use the 0.0477 whatever.
Not exactly. So here, let me show you guys.
Oh wait, I totally read that wrong. Never mind.
Yeah, so this is the thing I wanted to show you guys really quick. I'm going around to the groups and showing everybody. So everybody sees my Stat Crunch?
Yeah.
There's a standard in between. So if you go to standard, this gives you this one. It gives you sort of, you tell it you want it greater than or less than a certain value, and it gives you the percent, right? If you go between, it gives you, you want it between this number and this number. Does that make sense? The mean and the standard deviation, those come from the problem. So you can use the 8, I think it's like 9 and 0.5 or something like that. Or no, 0.3. Does that make sense? From the problem itself, from the original? Yeah, 9 and 0.3.
Okay.
Got it? And you want everything between 9 and 8.5, I think?
Yeah.
So that'll change when you plug it into here.
Okay.
Got it?
Yeah, because it's in between. So.
Right.
All right.
Yeah. All right, I think we got 5 minutes. I'm going to bring everybody back.
Okay.
Yay. Eventually, if I can figure out how this thing works. This thing is brand new for me. Okay. I'll see you guys back there. So this thing is actually pretty cool. I thought that we were gonna, for the most, like, I thought that by and large the group work portion was like not gonna happen. It turns out it's not too far off. So you guys that are joining in right now, I think everybody's currently muted. You can unmute yourselves, except for Antonio, because his mic is screwing over everybody.
That's feedback.
Yeah. I
You're
would.
already on.
Yep. So Antonio, I have the chat on if you want to ask me a question. We have to figure out the thing with your mic so that it doesn't listen into. But we'll do it after class.
That was 10 minutes.
That was 10 minutes.
Okay. We only got to be on number 6.
Huh?
We only got to be on number 6.
Oh, that's fine. We'll finish it up right
You're
now.
supposed to do 5 and 6, right?
Yeah.
We were actually getting it though. We got a little confused, but we made it through.
You made it through, yeah.
We did.
I like this. I like these little breakout groups that makes you go into groups. So
Is it going to be like different each like session though? Like the breakout?
I think so the groups that I just put you guys in, I did it twice.
It might change though
Same
based
group.
on the conference call if it has to
Yeah, I think
redo
it
it.
might be based on the conference call, yeah.
Oh yeah. Like if someone's not there or whatever, obviously.
Yeah, it'll just randomly pick us and put us in.
Right. But that's not bad though.
Mm-hmm.
Okay, so based on the data, I'm gonna just try to do number 6 really quick. Something new that you guys haven't seen yet. Based on the data, what is the probability that a baby is born weighing less than 6 pounds? What are we looking at?
So 6 and under.
Yep. Right, so from here
5, 4, and 6.
down, right? How big is each one of these boxes?
0.5.
Right, so each one of these boxes is 0.5. So what's the percentage for this one?
0.5 for that one.
Yeah,
0.5, yeah.
0.5%. And what's the one for the next one?
1%.
1%. And the next one?
3.5.
3.5%.
Wait, where'd the 0.5 come from?
Because like
0.01 times 0.5.
Yep.
Right.
Yeah, but where did the
0.05.
0.5 came from like when you're looking at each little individual thing. It's not going over by
it's
one.
in
it's going over by-
intervals?
Yes.
Yeah, it's like the interval is.
Okay.
Got it?
Yeah.
Boom. So we have our percents. So what's the probability that a baby is born weighing less than 6 pounds?
5%.
Right. A little more than 5% because we have no idea how big this one is.
Yeah.
Right? So we can do the rest of them though. So 3.5 plus 1 plus 0.5, that is our 5%, right? About.
Yes, sir.
About. Okay. Verify that the answer is close to the StatCrunch estimate. So that's the thing I actually wanted to do in front of people. So I'm going to share my StatCrunch. So the average is 7.7, and the standard deviation, does everybody see this?
Yes.
Yep.
Is
Oh,
1.
it's like the same thing we had to do for the last one, like the same kind of like calculation.
Yep. So I want less than 6, and I compute. So what's my percent?
6.1%.
6.1 and change, right? So go ahead, switch back. So our guess is 5%, right? But that's because we're using the actual boxes from the density function. The actual answer, well, the StatCrunch estimate is 6.1. Got it? Okay. C is gearing up for something that we're going to get to, I think, in 2.2. Probability that a baby's birth weight lies within 1 standard deviation. So what is within 1 standard deviation in this case?
I don't know.
What, plus or minus, or 7.7 plus or minus 1.1.
Right. And then 7.7.
Where did that come from, though?
So the mean and the standard deviation were given up here.
Oh, okay.
So within 1 standard deviation means above by 1 standard deviation and below by 1 standard deviation. So
Oh, I just didn't see that. I about the numbers being up there, but that makes sense.
okay. So plus 1 standard deviation, that is 8.8, right? And then minus 1 standard deviation, that is 6.6. So we go back to StatCrunch.
Yay.
Yay. Go back to StatCrunch. This is where we're going to use the between option. Got it? So we hit between. We change all the good stuff. So 6.6 and 7.7. No, sorry, 8.8.
8.8, yeah.
8.8. Computo.
And that gives us.
So what's my percent?
68.
68.2 and change about?
Yes.
There we go. So I'm going to just recreate the thing. So the mean is the 7.7, right? 1 up is 8.8. 1 down is 6.6. We need everything between here and here. And if we do that, this is the thing that we just did on StatCrunch, right?
Yes.
Looks weird, though.
Well, I didn't draw it exactly, if that's what you're referring to. Right? This percent is 68.2.
What? Okay.
I went over by 5 minutes. But I'm pretty sure you guys don't mind because you're already at home.
I guess.
At this point, you
Yeah.
can just turn on the TV.
So how did we get 6.1, but on C we got 68.2?
Well, notice how these work out, right? A, right? So A and B were sort of semi-tied together, right? A was find weighing less than 6 pounds. B was to verify, right? Less than 6 pounds from our graph, right, is supposed to be very small.
Right.
Right? And C deals with 1 standard deviation away. We found what 1 standard deviation away is, right? It's from 6.6 to 8.8. So we use that knowledge, go up to the graph. We are looking for everything in between 6.6 to 8.8. So that's everything from about here, right? All the way to 8.8, which would be around here. Does that make sense? So it makes sense.
That's on C.
Yeah.
So that's 8.5-ish.
Right.
Oh, yeah. That is 6.6 to 8.8.
It's supposed to be bigger because that's where most of the eggs are, right? Or sorry, that's where most of the babies are. Yeah. All right. What'd you guys think?
It was all right.
Not bad.
Not bad.
Yeah, not too bad.
Not too bad. All right, good. A lot of the other faculty are like, what the hell am I going to do?
I think it's doable.
Good thing you're good with your gizmo.
Tablet. Yeah, my gizmo.
Yeah.
Okay. So I took a couple more minutes than I'm supposed to, so I apologize. But like I said, you guys are already at home. I promise not to do this too often. Class is over. I'll just hang around here for maybe another like 10, 15 minutes if people have questions.
Yeah, quick question for you.
Yep.
So I know on Canvas the chapter 12 and 13 homework's supposed to be due tonight. Is that going to get?
Yeah, I'm gonna have to move that.
Okay.
We're barely starting 12.
So right now, what do you want us to finish for Canvas like by next class?
I guess
If you start 12 today, that's a good start.
Yeah.
Okay.
Because I think originally you had it 12 cut in half.
Right.
So half of 12 was due, I think, last week, and the other half was due today.
Wait, wasn't module 13 also due today?
Yes.
So
Yes.
I'm
No, it's
maybe sometime
yeah.
this weekend.
Because I assume by Thursday we'll either start 13 or finish 12.
Right. I think we will start. I think we're gonna finish up 12, start 13. Yeah.
Okay.
That's the hope, at least.
Can you email me about the testings? That's the only main thing I'm stressing about at the moment.
And who was that spoke? I have no idea.
Haley.
Oh, Haley. Okay. Yeah, that's fine.
Okay.
So we might need to schedule it sometime after we come back,
Okay.
if at all. If we do have that option, because everybody else took it in person.
Yeah.
So sort of to be on equal footing with everybody else, you would need to take it in person.
Okay.
Cool.
Yep.
So we'll figure it out.
Okay. Thank you.
Okay. Let's see. There was 2 questions in the chats. Let's go to the chats. Thank God this thing turns on when questions. Oh, bye, Sarah. Have fun, you guys. Stay safe. Don't go crazy. Go skinny dip in some hand sanitizer. I don't know.
Sounds like a bad UTI.
Yeah.
All right.
Yep. All right. I'll see you guys later. See you guys on Thursday.
So I got one last question. So on Canvas, I already finished module 12 and 13.
Cool.
So it says module 14 and 15 are due on Thursday.
I'm going to move stuff because we're barely on module 12 right now.
Okay, so I don't even have to worry about no work.
If you did module 12 already, you're good to go. I think you gave yourself a free day.
Yeah, because I did module 12 and 13.
Yep.
Okay. So I don't have to worry about anything.
No, I don't think so.
Okay.
Just make sure you have I'm going to start grading. I know I've said this multiple times already. I'm going to start grading the discussion soon, so make sure you post all your stuff there.
Yeah.
Okay.
Okay.
All right, Ruben. I'll see you.
I have another.
Yep, I'll see you on Thursday.
All right.
Woo. What a day.
Have a nice day.
You too, Leon. Stay safe.
Okie dokie. You too.
Yep, I'll see you on Thursday.
All right. I see him. I get to see him.
You see you?
I can turn my camera on.
I can't see him yet because you didn't turn on your camera, and that's okay.
That was my wife being nosy.
I was afraid of trying this because like right now I'm on my couch at home, right? And everybody else is probably as well. Who knows how they are dressed right now?
I'm literally sitting in my old man's chair.
Yeah.
Hey, I got my heater and vibrator on.
Oh man.
It's kind of cold today.
Yeah, it is very much so.
Yeah.
It was a little warmer earlier today. I saw the sun come out.
Yeah, for a second, huh?
Yeah. It was nice and warm. It gave it was maybe at around like a good 73, 72 degrees, nice and calm. But now the clouds are here.
Yeah.
It's real cold.
I don't even want to go outside.
Yeah. Maybe if this actually does go into April, I might just step outside one day and do the lecture out from like my little mini backyard or something.
That'd be nice.
Yeah.
All right, buddy. See, I'm gonna try to catch up on my modules though.
Okay. Yeah, you do that.
Okie dokie.
Yep. All right, man. I'll see you around.
All right, take care.
You too.